Alright guys, welcome to Russ's Chem Lab. And our topic for today is going to be vapor pressure. So to start off, let's erase this. We have a container here, a nice normal rectangular prism actually. Alright, 3D. So, in our prism we will have water. And as soon as this liquid is present, it'll start to evaporate, and those water molecules will continue to rise, and they are now a gas since they are able to leave. They are able to move freely around in the space above the water, which is now a gas. They are able to move freely around. They can either leave the container completely, or they can re-enter the water if they choose to do so. Keep in mind that when water evaporates and turns into a vapor, it is now a gas, and gases have pressure. So there's now pressure above the container, even though it's not being compressed because nothing is holding the gas from it. Nothing's holding it from leaving, so it's just moving freely. So now the interesting part is when we happen to put a lid on said container. So here's the lid. So now the gas and water have become trapped, and the water vapor is forced to go back into the water that originally came from. And eventually you'll get a state or a rate in which the water that is evaporating and turning into a gas is equivalent to the rate at which the water that is a gas is going through condensation and turning back into a liquid. And when this happens, when these rates are both equal to each other, you get something called equilibrium, which is where the rates are the same, where the rate of change is the same.